Okay, so here we're going to continue on with lesson 9.6. So we previously talked about factoring completely, okay? So the ones that we previous did, we were able to factor them because the first term and the last term were perfect squares, okay? So if we look here at this one, we have 25r squared plus 5r minus 6, okay? So if we look at the first term, 25, yes, this is a perfect square because it's 5 squared. But if we look at the last term, 6, this is not a perfect square, okay? So this is not a perfect square trinomial, and we're not able to factor it like we previously did. Okay, so just to show you another example here, okay, this is 18r squared plus 24r plus 8. Okay, so let's check the first term. 18. No, this is not a perfect square. 8. Nope, this is not a perfect square. So the whole entire thing is not a perfect square trinomial. Okay, so we're not able to factor this the way that we previously did. Okay, so the next part of this lesson is trying to use the square root property in order to solve for a. Okay, so whenever we have an equal sign here, it means we want to solve for the variable. So I'm going to go ahead and rewrite the equation. A plus 4 squared is equal to 49. Okay, so because 49 here is a square, I can take the square root of it. So whatever I do to one side, I have to do to the other in equations. Okay, so a plus 4 squared, if I take the square root, I just get a plus 4. And the square root of 49 could either be positive 7 or negative 7. So it's plus or minus 7, okay? So the reason, if we think negative 7 times negative 7 equals 49, and also positive 7 times positive 7 equals 49. So that's how I got the plus or minus 7, okay? So now I actually have two equations here, okay? I have a plus 4 equals 7, and I also have a plus 4 could equal negative 7. Okay, solving for a, I get a is equal to 3, and solving for a over here, I get a is equal to negative 11. Okay, so I have two answers here. A is 3, and a is negative 11. Okay, let's try another one together. Okay, so this one we see that we first need to factor. Okay, again, if you look in your notes, this is y squared. So what we want to do here is first look and see if this is a perfect square trinomial. Okay, so I see that the first term is a perfect square because y squared is just y. Okay, and then the last term is also a perfect square because 4 is 2 squared, which is 2. Okay, so I have my first term and my last term. Then I want to check to see if the middle term is 2 times the first term times the last term. And yes, it is. Okay, I also see that because I have a minus, I'm going to use subtraction. Okay, so the first term minus the second term squared. Okay, I was able to use the perfect square trinomial to factor here, which is equal to 25. Okay, let me just divide this off. All right, so now this problem looks like the first one that I did. I see that 25 is a perfect square, so I can take the square root, and I can take the square root of this side also because it's squared. When I take the square root, I get y minus 2. And the square root of 25 could be positive 5 or negative 5. So I write it as plus or minus 5. Now I have two equations. I have y minus 2 is equal to 5. And I also have y minus 2 is equal to negative 5. Okay, so solving for y in both. Here I have y is equal to 7. And here I have y is equal to negative 3. Okay, so two answers. Y is 7 and y is negative 3. Okay, so I'd like you to pause the video for a moment and try this one on your own. Okay, So here this is x minus 3 squared is equal to 5. Okay, I'm going to go ahead and rewrite it down here, and let's see how you did. Okay, so we see that on the left-hand side, we already have it in factored form. Okay, so and on the right-hand side, I see that 5 is not a perfect square, but I'm still going to try and take the square root of both sides using the formula. So square root of both sides, and I have x minus 3 is equal to, and I'm going to put plus or minus the square root of 5. Okay, so the reason I'm doing that is because I could have two negative numbers that multiply to be the square root of negative 5, but I can't actually take the square root because it's going to be in decimal form. Okay, so this one changes a little bit. So here now when I'm going to solve for x, I just need to add 3 to both sides. Okay, so here it eliminates, and I have x is equal to 3, and then I still have this plus or minus the square root of 5. Okay, so this technically is two answers, but it can just be written one way. Okay, you could also understand it as x is equal to, oops, sorry, wrote it twice. X is equal to 3 plus whatever the square root of 5 is. Okay, and x is equal to 3 minus the square root of 5. Okay, so if you want to get a full answer, you could type that in your calculator and see. But this right here is how it should be written as your final answer. Okay? All right, so in this lesson, we kind of just went into a little more detail on how to factor completely and what to do if you can't. Okay? And also how to use the square root property whenever you have an equal sign to solve for a variable.